In this video, we will be talking about one of the most powerful technologies that Microsoft has ever used for virtualization. Hyper-V is Microsoft's hardware virtualization product. It lets you create and run a software version of a computer called a virtual machine. Each virtual machine acts like a complete computer running on an operating system and programs. When you need computing resources, virtual machines give you more flexibility, help save time and money, and are a more efficient way to use hardware than just running one operating system on physical hardware. Hyper-V runs each virtual machine in its own isolated space, which means you can run more than one virtual machine on the same hardware at the same time. You might want to do this to avoid problems such as crashing after the other workloads, or to give different people, groups, or services access to different systems. Whether you are a software developer, an IT professional, or a technology enthusiast, many of you need to run multiple operating systems. Hyper-V lets you run multiple operating systems as virtual machines on Windows. Hyper-V specifically provides hardware virtualization. That means each virtual machine runs on virtual hardware. Hyper-V lets you create virtual hard drives, virtual switches, and a number of other virtual devices, all of which can be added to the virtual machine. Virtual machines and virtualization allow you to run software that requires an older version of Windows or non-Windows operating systems. Experiment with other operating systems. Hyper-V makes it very easy to create and remove different operating systems. Test software on multiple operating systems using multiple virtual machines. With Hyper-V, you can run them all on a single desktop or laptop computer. These virtual machines can be exported and then imported into any other Hyper-V system, including Azure. Hyper-V can help you establish or expand a private cloud environment, provide more flexible, on-demand IT services by moving to or expanding your use of shared resources, and adjust utilization as demand changes. Use your hardware more effectively. Consolidate servers and workloads onto fewer, more powerful physical computers to use less power and physical space. Improve business continuity. Minimize the impact of both the scheduled and unscheduled downtime of your workloads. Establish or expand a virtual desktop infrastructure or VDI. Use a centralized desktop strategy with VDI can help you increase business agility and data security, as well as simplify regulatory compliance and manage desktop operating systems and applications. Also, deploy Hyper-V and remote desktop virtualization host (RD virtualization host) on the same server to make personal virtual desktops or virtual desktop pool available to your users and customers. Make development and test more efficient. Reproduce different computing environment without having to buy or maintain all the hardware you'd need if you only used physical systems. Hyper-V in Windows and Windows Server replaces older hardware virtualization products such as Microsoft Virtual PC, Microsoft Virtual Server, and Windows Virtual PC. Hyper-V offers networking, performance, storage, and security features not available in these older products. Hyper-V and most third-party virtualization applications that require the same processor features aren't compatible. That's because the processor features, known as hardware virtualization extensions, are designed to not be shared. Therefore, if any other virtualization application is coexisting with Hyper-V, they will not be compatible. Hyper-V offers many features. Remember, this video is just an overview. Therefore, we're not going to go very deep into every single one of those. That keeps the door open for the viewer of this video to do more research. Computing environment. A Hyper-V virtual machine includes the same basic parts as a physical computer, such as memory, processor, storage, and networking. All these parts have features and options that you can configure different ways to meet different needs. Storage and networking can each be considered categories of their own because of the many ways you can configure them. Disaster recovery and backup. For disaster recovery, Hyper-V Replica creates copies of virtual machines intended to be stored in another physical location, so you can restore the virtual machines from the copy. For backup, Hyper-V offers two types. One uses saved stats, and the other uses volume shadow copy service or VSS. So you can make application consistent backups for programs that actually support VSS. Optimization. Each supported guest operating system has a customized set of services and drivers called integration services that make it easier to use the operating system in a Hyper-V virtual machine. Portability. Features such as live migration, storage migration, and import-export make it easier to move or distribute a virtual machine. Remote connectivity. Hyper-V includes virtual machine connection, a remote connection tool for use with both Windows and Linux. Unlike remote desktop, this tool gives you console access, so you can see what's happening in the guest even when the operating system isn't booted yet. Security. Secure boot and shielded virtual machines help protect against malware and other unauthorized access to a virtual machine and its data. Hyper-V is available in Windows Server and Windows as a server role available for x64 versions of Windows Server. For server instructions, you have to go to install the Hyper-V role on Windows Server link. On Windows, it's available as a feature in some 64-bit versions of Windows, which we will be discussing more down in this video. It's also available as a download, standalone server product at Microsoft Hyper-V Server. Hyper-V is a physical-based virtualization technology. Hyper-V uses the Windows hypervisor, which requires a physical processor with specific features. In most cases, the hypervisor manages the interactions between the hardware and the virtual machines. This hypervisor-controlled access to the hardware gives virtual machines the isolated environment in which they run. In some configurations, a virtual machine or the operating system running in the virtual machine has direct access to graphics, networking, or storage hardware. Hyper-V has required parts that work together so you can create and run virtual machines. Together, these parts are called virtualization platform. They're installed as a set when you install the Hyper-V role. The required parts include Windows Hypervisor, Hyper-V Virtual Machine Management Service, the Virtualization WMI Provider, the Virtual Machines Bus or VM Bus, Virtualization Service Provider or VSP, and Virtual Infrastructure Driver or VID. Hyper-V also has tools for management and connectivity. You can install these on the same computer that Hyper-V role is installed on, and on computers without Hyper-V role installed. These tools are Hyper-V Manager, Hyper-V Module for Windows PowerShell, Virtual Machine Connection, sometimes called VM Connect, and Windows PowerShell Direct. There are some technologies from Microsoft that are often used along with Hyper-V. Technologies like failover clustering, remote desktop services, System Center, Virtual Machine Manager. Various storage technologies, cluster and shared volumes, SMB 3.0, and Storage Space Direct also are being used along with the virtual machines of the Hyper-V. Windows containers offer another approach to virtualization, which is actually out of the scope of this video. But if you're interested, look up Windows containers on the libraries on MSDN. Now let's talk about the system requirements that you need for Hyper-V. Hyper-V is available on 64-bit versions of Windows 10 Pro, Enterprise, and Education. Remember, it is not available on the Home, Mobile, and Mobile Enterprise editions of Windows 10. Most computers will run Hyper-V, however, each virtual machine is completely separate operating system. You can generally run one or more virtual machines on a computer with 4 GB of RAM, though you'll need more resources for additional virtual machines or install and run resource-intense software like games, Windows videos editing, or engineering design software. If you consider a current modern operating system, existing 4 GB of RAM is only enough for the virtual machine for the underlying machine itself. However, if you want to install multiple virtual machines on there and assign each one a couple of megabytes of RAM or gigabytes of RAM, then you will be running out of RAM pretty quick. So if you're using a machine to run multiple virtual machines, you have to understand that you need to add as much RAM as your budget lets you to prepare that machine for smooth virtual machine experience. 64-bit processor with second-level address translation or SLAT is needed. Basically, we are talking about good Intel Core i5, 7, and 9 at this point. Remember, 32-bit processors cannot run the latest version of the Hyper-V. CPU support for VM Monitor Mode Extension or VTC on Intel CPUs is another requirement. Minimum of 4 GB of memory, as we said. As virtual machines share memory with the Hyper-V host, you will need to provide enough memory to handle the expected virtual workload, along with handling the workload of the physical machine that is running the virtual machines on. The following items will need to be enabled in the system BIOS. So you have to enable virtualization technology. It may have a different label depending on motherboard manufacturers, and you have to enable hardware-enforced data execution prevention. If you don't do this, you're going to have some issues while using the Hyper-V. To verify compatibility of your hardware, open up PowerShell or a command prompt and type system info. What you see here in this screenshot is something like the report you're going to receive. If all listed Hyper-V environments have a value of yes, as you can see here, then your system can run the Hyper-V role. If any item returns no, you have to check the requirements listed and make adjustment where possible. So this is a very important step before you even start using your physical computer for virtualization. If there is an existing Hyper-V and you run the command system info on the existing Hyper-V host, the Hyper-V requirements section will read, a hypervisor has been detected. Features required for Hyper-V will not be displayed. So basically, if you have a Hyper-V, you cannot create another virtualized Hyper-V virtual machine within that Hyper-V environment. Integration services, often called integration components, are services that allow the virtual machine to communicate with the Hyper-V host. Many of these services are conveniences while other can be quite important to the virtual machine's ability to function correctly. If those services are not in place and properly configured, again, your virtualization experience will be very bumpy. In the coming slides, I will first show you a list of those services, and then we will dive deeper into each one of those services together. So these are the services, a part of the services that are available. So we have the Hyper-V Heartbeat service, Hyper-V Guest Shutdown service, Hyper-V Time Synchronization service, Hyper-V Data Exchange service. We have Hyper-V Volume Shadow Copy Requester, Hyper-V Guest Service Interface, and Hyper-V PowerShell Direct Service. These tables would be a very good location for you to come back and take a look at as a reference in future whenever you want to figure out what services do what. And the part that is really important for you to look at are the impacts on the virtual machine when disabled. So as you can see, some of them have very high impact on the virtual machine, like the Hyper-V Guest Shutdown service. Some have a medium one, like Hyper-V Data Exchange Service or KVP. And some, they have different impacts depending on the situation. So like the Heartbeat service may have a very low impact or a very high or medium impact based on the infrastructure you are designing for your business. Some like Hyper-V Guest Service Interface have a very low impact. Now, let's take a look at each one of these in more details. First service we're going to look at is Hyper-V Heartbeat service. The Windows service name is basically what the service is being represented with under a Windows machine. A Linux daemon name is the name that the service is going to be represented on a Linux machine. And as you can see, those are different depending on the system. For each service, we're going to talk about a description. We're going to talk about the added-in, which is going to tell us when the service started being available in Hyper-V. And then finally, we will talk about the impact. So Heartbeat service tells the Hyper-V host that the virtual machine has an operating system installed and that is booted correctly. The service was added in Windows Server 2012 and Windows 8. And when the service be disabled, the virtual machine can't report that the operating system inside of the virtual machine is operating correctly. This may impact some kinds of monitoring and host-side diagnostics. So basically, this service lets you know if your virtual machine is healthy, working, booted properly with no issues. Most of the combined monitoring services need this service to be enabled in order to be able to report back to you. The Heartbeat service makes it possible to answer basic questions like, did the virtual machine boot? When Hyper-V reports that a virtual machine state is running, it means Hyper-V set aside resources for a virtual machine. It does not mean that there is an operating system installed or functioning. It's just about the allocation of those resources. This is where the Heartbeat becomes useful. The Heartbeat service tells Hyper-V that one operating system inside the virtual machine has booted. You can check the Heartbeat with PowerShell. Run get-vm command, as you can see here on the slide, as administrator to see a virtual machine's heartbeat. Your output should be looking like this. So you see the name, the state, and the status. The status field is determined by the Heartbeat service. Now let's talk about Hyper-V Guest Shutdown service. As you can see, a Windows service name and Linux daemon names are available. And this service allows the Hyper-V, the host, to request that the virtual machine shut down. So a shutdown request is going to be sent to the virtual machine that exists on the Hyper-V. The host can always force the virtual machine to turn off, but that is like flipping the power switch as opposed to selecting the shutdown, which in some cases it can affect the virtual machine or the files which were open on the virtual machine before that power off switch goes on. It was added in Windows Server 2012 on Windows 8, and when disabled, the host can't trigger a friendly shutdown inside the virtual machine. Therefore, all shutdowns will be hard power off, which could cause data loss or data corruption. The other service is Hyper-V Time Synchronization Service that synchronizes the virtual machine's system clock with the system clock of the physical computer. I believe without no explanation, you can guess how important it is. It has started to be added in Windows Server 2012 and Windows 8. When disabled, the virtual machine's clock will drift erratically. Hyper-V Data Exchange Service, or KVP, provides a mechanism to exchange basic metadata between the virtual machine and the host. Was added in Windows Server 2012 and Windows 8. When disabled, virtual machines running Windows 8 or Windows Server 2012 or earlier will not receive updates to Hyper-V Integration Service. Disabling data exchange may also impact some kind of monitoring and host site diagnostics. The Data Exchange Service, sometimes called KVP, shares a small amounts of machine information between virtual machines and the Hyper-V host using the Key Value Pairs, or KVP, through Windows Registry. The same mechanism can also be used to share customized data between the virtual machine and the host. Key value pairs consist of a key and a value. Both the key and the value are strings. No other data types are supported. When a key value pair is created or changed, it is visible to the guest and the host. The key value pair information is transferred across the Hyper-V VM bus and does not require any kind of network connection between the guest and the Hyper-V host. An example of how to add a new key value pair in the guest is like this. In this example, the value of status is set to be ready. Take a moment and look at how the command looks like. You can use the same syntax to change the value of the key to not ready or anything else that you want. So basically this is the value over here. Let's take a look at another example. Querying for a key value and the guest. So to query for the value of the external subkey containing the data pushed to the guest from the host, you can run a command like this. Take a moment and look at it. Now let's talk about Hyper-V Volume Shadow Copy Requester, which allows Volume Shadow Copy service to back up applications and data on the virtual machine. When disabled, the virtual machine cannot be backed up while running using VSS. So basically you need to turn it off before you can back it up. The live status will not happen. The Volume Shadow Copy Requester Integration Service is required for Volume Shadow Copy Service, or VSS. The Volume Shadow Copy Service, VSS, captures and copies images for backup on running systems, particularly servers. Imagine if you need to turn off your server every time you want to back it up. This means the backup happens without unduly degrading the performance and stability of the services you provide. This integration service makes that possible by coordinating the virtual machine's workloads with the host's backup process. Hyper-V Guest Service Interface provides an interface for the Hyper-V host to bidirectionally copy files to or from the virtual machines. It was added in Windows 2012 R2 and Windows 8.1. As you can see, this is a newer service. When disabled, the host cannot copy files to and from the guest using copy VM file. Note that this is disabled by default, and if you want it, you have to enable it yourselves. Hyper-V PowerShell Direct Service provides a mechanism to manage virtual machines with PowerShell via VM session without a virtual network. This one was added in Windows Server TP3 and Windows 10, almost one of the newest ones. Disabling this service prevents the host from being able to connect to the virtual machine with PowerShell Direct. And finally, let's talk about Hyper-V PowerShell Direct Service itself. The service name was originally Hyper-V VM Session Service. PowerShell Direct is under active development and only available on Windows 10, Windows Server Technical Preview or TP3, or later host guests. PowerShell Direct allows PowerShell management inside a virtual machine from the Hyper-V host, regardless of any network configuration or remote management settings on either the Hyper-V host or the virtual machine. This makes it easier for Hyper-V administrators to automate and script management and configure the tasks. Now let's take a look at a demo. This is a step-by-step guide, a demo credited and created by CodeCowboy.org, and you can see the link on the screen. I'm adding the video to the continuation of this one, so you can just refer to one video for everything.
Hi, so in this tutorial I'm going to show you how to install Hyper-V, go through setting up a virtual switch and also creating VMs. So first I'm going to talk about the hardware that I'm installing this on, and I understand in the corporate environment you're going to have probably a 32 core or a 64 core physical machine. So in my case, this is a lab machine of mine, so I just have a AMD 6 core and 24 gigs, and I plan on using 2 to 4 gigs per VM that I create. So the hardware itself has 2 Ethernet cards, one for the host and one for the VM. So each of these are gigabit Ethernet cards, and this particular one that I've highlighted here is for the host machine, while this will be reserved for the virtual switch where all of the VM traffic will go through. So this one will be the core of the virtual switch created under Hyper-V. As far as disk drives, it's very likely in the corporate world you're going to have a SAN. In my case, I have a local 2 terabyte hard drive and also a SSD drive that is half a gig. So I'll be storing most of my 40 gigs to 60 gig VMs in this SSD drive, while some of the backups or some of the little used VMs will be in the hard drive itself. So that is the hardware that I am going to install this on. So I'm just going to go right ahead and bring up Server Manager and start installing Hyper-V. So first I am going to click on Add Roles and Features, and what I'm going to do is click Next and select Role-Based or Feature-Based Installation. I've selected the current server that I am on, and just checking off the Hyper-V. So when I check off the Hyper-V here in the server roles, it'll bring up some prerequisites, so I am going to add those features. And once I add those features, I'm going to click Next, and Next again, and Next. So this here is prompting me to reserve one of the Ethernet cards for a virtual switch. I am actually going to do that later in the Hyper-V Manager, so I am just going to click Next. So this screen here is prompting me for live migration, which is the migrating of the VMs from server to server on your Hyper-V cluster. And I am not supporting this currently, so I am just going to click Next. So this is prompting me to place the virtual hard disk and also the configuration files. I actually do have a pre-defined location for that, which is on my SSD drive. So I am going to go to the E drive, and I have my virtual hard disk here. So I'm going to put in that folder, and also my config files here. And once that is defined, I am going to click Next. And now I'm simply going to confirm and click Install. And this will take about 5 to 10 minutes to install. So I'm going to pause the video here and wait for the installation to complete. Now the installation completed in about 2 minutes, and as you can see, it prompts me and requires a restart. So I'm going to go ahead and restart my server here. So my server's boot back up, so now I can configure my Hyper-V Manager. So I'm going to go into Tools under Server Manager here and go to Hyper-V Manager. And the first thing I'm going to have to do is set up my virtual switch. So I am going to highlight the computer or server, click on Virtual Switch, and I'm going to select External. So what I'm creating over here is going to be a virtual switch that is in parallel with my host machine. So when I create this virtual switch and assign it to my VMs, what's going to happen is those VMs will be able to reach the same DHCP as if it was on the same network as my host. So I am going to select Create Virtual Switch here, selecting External. And I am going to type in here Hyper-V external virtual switch. And this is the controller that I want to choose. So this is the controller that I have reserved for the VMs, while this one, the PCIe, is actually the controller for my host machine. And so I am going to select Apply and click Yes. And this will take just a couple of seconds here while it creates the virtual switch. And so I am going to click OK. And now I am ready to create my virtual machines. But before I do that, I want to show you what that creates. So if I go into my network and I open up the network sharing and I choose Change Adapter Settings, you'll notice it created the virtual switch here. And again, this is going to be basically the network card, which is this physical network card here. And this physical network card is not going to have an IP because the individual virtual machines that I create pointing to this virtual switch will have the IP addresses, and I will demonstrate that after I create the VMs. So let's go back to virtual Hyper-V Manager, and I'm going to right click on my server, say New Virtual Machine, and go through this wizard here, and I will just name it Cobra. And that will be my default location where I have all my virtual machines. And I am going to select, so I'm just going to select generation 1 here. And click Next. And I will be giving this 4 gigs. 96. And I'll requesting to use dynamic memory, meaning that it will only reserve memory that is actually occupied or in use, not the full chunk up front. And the connection here is my virtual switch, and again this will create the network adapter within the VM that will go through my physical drive, my physical network card. And I am going to say 40 gigs here. or 60 gigs. And again, that is exactly what I want. So I'm going to say next. And I do want to point it to a bootable CD-ROM. I'm going to browse to that, which is on my E drive. On my D drive here, under ISO root, I am going to select a outdated version of Windows 2016 Technical Preview. I'm going to click Next. And this will simply start the installation here. So once I right click and say Connect and turn on the virtual machine here, it will go into basically the post boot up mode as it normally would, loading the files. So I'm not going to go through all of this. I am just going to install the operating system, then show you the network card and the configuration of the network card within this. And as you can see, I am simply going to click Install Now. And I will simply fast forward here. As you can see, this is, or actually let me show you the virtual hard disk, the 60 gig drive that it'll detect here. So as you can see, it lets me choose the operating system. That's from my ISO. I'm just going to simply click Next. I'm going to have a desktop for my preview, accept it. And here you'll notice this is the 60 gig hard drive that I've created, and I'm simply going to click Next. And it's simply going to start copying and installing the file. So I'm going to pause here and I'm going to wait until this installs and then show you exactly how to configure the network card itself and the network connections from the VM. From within the VM, I'll show you the network connections and network adapter configuration, just as if it was a physical machine. So I'm going to pause here and wait until this finishes installing. So let me just configure this really quickly after it's installed the initial files. And it's logging in. And let me send the Control-Alt-Delete. So now this is like any physical machine. You're going to set up RDP on here. And I'm going to give it an IP address on the same network segment as my host. So everything here is loading initially now, and this network prompt comes up. So the network adapter is active. I'm going to say no, make it not discoverable. And I am going to open this up. Well, what I really want to do here is open up the network. So notice I am simply going to now go into the change adapter settings, and you'll notice I have a Ethernet adapter here. Click on Properties. IP address, and I can assign it the IP addresses that is in the same network segment as my host. 88. So I'm just going to start. You know what? I am going to start with 150 here and have the same network gateway. And the same DNS server that I have on my host. Click OK here. So now I could actually go on the internet, and also let me set up my remote desktop here. So if I go open up the properties here. Oops, wrong item. Go under remote and allow connections. Click apply. And if now this is my host machine. I'm going to open up the terminal services client. And actually that is the wrong one. Microsoft Terminal Services Client. Open that up. And if I type in the IP address 192.168.88.150, you'll notice I'm prompted to connect. And my initial connection is simply administrator. And that is actually the machine name, the default machine name that was assigned. So now I am just RDP'd into my VM here. And what you'll notice from my VM, let's see if I could, okay, so my Internet Explorer is actually not activated. Let me log out here. And so let me log out. Or actually, let me simply restart my virtual machine. So notice in the background here, via the Hyper-V Manager, my virtual machine's restarting. But as you can see, now everything's already set up, and I'm able to remote desktop to my VM, and the VM itself is able to get onto the internet. And let me demonstrate that. So you notice when I set up my virtual switch, having it tied to the remote, having it tied to the VM here, and I am simply logging in. So as you can see, this is precisely why I'm glad I've put everything on an SSD drive. Okay, so I do not have my Microsoft Edge activated. Let me try to pull up Internet Explorer. So I'm going to have to enable my Internet Explorer, so let me go ahead and do that, or my Microsoft Edge. I'm going to do setpoll.msc. Now, of course, all of this is unrelated to the Hyper-V Manager now that I have the VM up and the network adapter is obviously working. But I do want to demonstrate that the internet does work, so this is the rights that I actually have to enable. And I'll have to log out for this. So now that I have that enabled, shut down. -L -T now, or T1, or just shut down, logging out, and I'm going to log back in and demonstrate for you that this can actually go on the internet. So I'm gonna now go into Microsoft Edge, and again, this is an outdated version of the Windows 2016 that I've installed. So as you can see, it already went on to the internet. And if I go to Google, you'll notice it'll bring up Google here. And what I want to do here is also RDP in one more time. So this is the VM via Hyper-V Manager. I am going to go in and bring up my remote desktop again and connect right to the VM. And as you can see, now I'm connected to that VM. And that's really it. That's really what I wanted to show. It was a little bit longer than I thought to actually demonstrate the creation of a VM. But I really did want to do an end-to-end, a complete end-to-end here. And there you go. That's really it. And I hope this helps. And please subscribe if this was helpful. And thank you for watching.